Karl Witbeck. I'm with Valley Metro Rail. I'm one of the engineers on the light rail project. And we're here today to have a lesson about what is an engineer. A lot of people ask me, what do I do? My kids ask me, what do you do at work, Dad? And so I thought we'd talk a little bit about that today, and then we're going to do a project that you'll have fun with. Plus, you'll get to have snacks at the end. So, question is, what does an engineer do? So, you see examples of what engineers do all around you every day. When you drive your car, you go on a plane, when you ride a train, when you drive on a road, a bridge, you enter a building, you ride the light rail train here. All of those are examples of things that engineers have designed. And we also do lots of other things. We invent new technologies, we invent new products. Your smartphone that we all know and love, this was invented by a whole bunch of engineers. This is only about 20 years old. Your laptop, your iPad, your tablets, a lot of your video games that you use, all of those were invented by an engineer. We also are typically noted for analyzing numbers and data, things like that. And we also build and test machines, build prototypes, and all that sort of thing. If you ever watch any of the movies about the missions to the moon, you'll see lots of different types of engineers that are used to build the space shuttle, for example. So people ask me, what type of engineer are you? They don't really know what an engineer is. And there are lots of types of engineering. There are electrical engineers that do things with obviously electricity and wires and cabling. There are mechanical engineers that do things with plumbing and your air conditioning at your house, all kinds of things like that. There are structural engineers that design bridges and buildings. There are chemical engineers. All of your drugs and pharmaceuticals and cleaning products, those were all designed by a chemical engineer. You have agricultural engineers that design how to best grow products that you eat at your table every day. There are civil engineers that do all types of roadways and dams. Here in Arizona, we have big canals that run through the state that send water from the mountains down here to the valley. Those are all done by civil engineers. There are communications engineers that obviously work on your telephone systems, your cell phones, your internet connection at your house. Those are all examples of things that communications engineers design. So those are a sampling of different types of engineers. My personal background is in the communications and electrical background, and get involved with all sorts of networks and radios and communications, things like that. When you ride the train, you hear announcements on the public address system. That's an example of a communications design of speakers that produce messages about the next station, when the next train is arriving, that sort of thing. So that's a quick introduction into what is an engineer. So today's project is going to be a balance project, understanding the concepts of mass and weight, and that there is such a thing as called leverage or cantilevers. And these are typically concepts that would apply to being a structural engineer. So if you want to be a structural engineer, this assignment would be particularly of interest to you. And so today we are going to show you how to build a very simple example of a balance. And you can do this at home with nothing but marshmallows and toothpicks and sticks. And so join me for this next session to build this project. Okay, so today we're going to use fairly simple items. We're going to use a bag of marshmallows. We are going to use some bamboo sticks, and we are going to use a ruler and some pieces of paper and a pencil. So the project today is to build a structure out of sticks and marshmallows. So we're using the marshmallows to act as connectors between these sticks, and these sticks represents beams or structural elements of a building. And so when you build a structure and you support it, it has to be balanced. So this example here, I pre-built this, and we'll build another one here in a minute, but I wanted to show you the basis of the project. So what we want to do is have this thing set up so that this marshmallow becomes my center point of my structure. So center point means that this is the point in the middle of the structure where it's balanced. So before I do that, let me just show you a basic concept. So if you were to take this ruler and just put your finger here, there would be a point at which I could balance it on my finger. So I picked the middle point. Now this is a 12-inch ruler. So if I put my fingers at 6 inches, which is in the middle, then it's balanced, right? If I put it over here, then it's just going to fall off my finger. So the same concept is here. So I have my marshmallow in the middle here, at least I think it's in the middle. So if I put my finger here, oh, it's a little bit out of balance. So what we need to do is adjust this marshmallow to be more in the middle. Maybe that's it. And we will, I'm getting close, so it's a little bit the other way now. So we move it back and find the middle here. There we go. So now we found the exact middle point of our structure. Is perfectly balanced. Now this concept is used in lots of different fields. So for example, if you've ever been to the circus and you have the guys in the high wire act, sometimes they will carry a stick or a rod. And what that does is that helps them balance themselves. So they stand in the middle of their stick and they walk, and it helps them keep a balance. So this is the idea. So what we're going to do next, I'm going to show you how to build this, and then we're going to show you how to find the center. So again, you're going to take your marshmallows here. Might as well just eat one. I don't know. Gotta have a snack. So we're going to put a marshmallow here in the middle. We're going to put one at the end. Okay, so there is our centerpiece. So I could just attempt to balance it. It's kind of hard to do. So it's really hard to balance it with just that. So what we're going to do is we are going to add some weight underneath it to help it balance. So we're going to get 2 more marshmallows here and 2 more shorter sticks. You can use a toothpick, or you can just break off these sticks and make some shorter ones. So what we're going to do is we're going to stick a marshmallow here. We're going to stick a marshmallow here. And then we're going to stick one in the top. And we're going to stick another one in the top. And then we're going to take this piece that we just built a minute ago. And we're going to stick it together here. And we're going to stick it here. So now we have an entire structure here. And so I'm going to attempt to balance it. So there we go. Now, so your assignment is to build this. Now let me show you a couple things to help you figure out where the exact balance point is. Because if you move this marshmallow to one side, and look at that, see it goes out of balance. Or if you were to hold it here, it would go like that. So again, we want to move this into the middle and find our balance point. And where was here? So right about there. So there's our balance point. Now, one of the things that engineers are notorious for doing is making drawings. So let's make a drawing of this, and have the camera zoom in here. So I've started my sketch here, and engineers typically start with a sketch. So we have our 3 marshmallows, and then we have our other marshmallow down here. Okay, we have another marshmallow here. Okay, and then we have our beam that goes across here. So the exercise is, how would you mathematically or using geometric techniques or geometry, if any of you taken geometry in school, how would you calculate where the center of this is? So what you would do is, since you want this to be in the middle, you would take this and you would draw a line straight down here. So this is, if it's level, so if you hold this up here perfectly in the middle, this line would go straight down. Then what you'd want to do is you'd want to figure out where the exact middle of this is. So if you were to put this on a scale and weigh it, there would be a point in the middle here that would be the exact middle. So what you want to do is create crossing lines to find the middle. So what you can do is, as I demonstrated earlier, if you hold this here like that in the exact middle of that stick, then it falls straight down. So what we'll do is we'll draw a line in the middle here. So now we have a point here, a cross point, and then what we do is, to further find this, we draw a line diagonally, and where these three lines meet is your exact middle. So let me just circle that. So that point there where the lines intersect would be your precise middle of your structure. So get out your paper and your pencils and your marshmallows and see if you can find the middle of your structure, and let me know and have fun with that. So we're going to first try to balance this with just the 3 marshmallows, and you can see how you have to have that marshmallow exactly in the middle, otherwise it's going to fall right off your finger. Wow, nice. Oh, hard to do. So the question is, so you could attempt to balance it here, but it's such a precise thing that it's hard to do. You can just about get it like that. But it makes it a lot easier when you add some balance weight to this. So I can get it to balance like that. Oh, lost it. But if I add the rest of my structure to it here, then I find it a lot more balanced, and weight is distributed now. And so you can now see how much easier that is. You don't have to work very hard. So the reason is that now the mass of this thing is distributed all the way around instead of just at the top. So the middle of the mass is in here, just underneath this marshmallow, where my finger is. So when you see an acrobat doing this, he's balancing stuff. Like I've seen acrobats with structure that look similar to this as they walk across. So it makes it a lot easier to balance because you have more weight that's distributed. So this is a concept of structural balance and distribution of mass or weight. So these are terms that you will learn in school if you do any science or technology. So this is an example of a STEM class, or science, technology, engineering, and math. And so this is an example of engineering or technology exercise. Very simple, obviously. So for the advanced class, you could build a double cantilever. So let's say we want to make this thing a little bit stronger here, because it's kind of wobbly here. So what we're going to do is we are going to design some cross members. Wow, that's pretty wobbly. So what we'll do is we'll take a stick here and we'll go across like that. So we're going to measure it. That's our precise measurement there. And then what we're going to do is we're going to stick one end in here, and then the other end in here. And now you can see that end is much stiffer, and we can do the same thing on this side. So we can take a stick and measure that there. And we are going to stick one end in here, stick another end in here. So now you can see it's a little bit easier to stand up, but now we're going to need another cross member. So let's see if this is long enough here. Yeah, so let's add another cross member here. So we'll stick one in here, and we'll stick one in here. So now this thing is a lot stronger just by adding 3 sticks. So now you can, in fact, we could add another one on the other side, going this way, to give it even more strength. So now this thing will, well, maybe not. It will stand up a lot easier on its own, like that, because it's got supports. Well, so if you wanted to give this even more strength, what you would do is you would build a truss across the top, like your roof on your house. So what you could do is you could take 2 sticks here. So you got to make let's just cut these in half. So let's say about that way. So I would take one of these here and do that. Take my other half. Do that, and then take my toothpick here, put it in here, put this in there. So there's our truss. So this is a standard truss right here. So most of your homes, if you were to look above the ceiling in this building here at your house, you would see something that looks like that supports your roof. So if you push down on this, you can see how it resists my pressure here. If I just push this in, it gives a lot quicker. This one here can withstand a lot more force because it's called a truss. Okay, so the calculation that we're looking for you to do is to calculate the middle of the mass or the weight of this device. So each of these marshmallows have a certain weight to them. Now let's assume for the moment that this is 1 ounce. These are each equal 1 ounce. Okay. So this is also 1 ounce. 1 ounce. So the weight of your 5 marshmallows would be 5 marshmallows. So you have 5 times 1 equals 5 ounces. Okay, and let's just say that all of your sticks weigh 1 ounce. So our sticks weigh 1 ounce. So our total here would be 6 ounces. So since we were holding it in the middle here, our middle point is right down the middle here. And then what we're looking to do is create a cross section in the middle here. So it would be basically, you go across here like this, and then you go across here like that. So this point here right in the middle would be the exact middle of your 6 ounce structure. So if you were to put this on a scale, which we don't have right now, it would weigh 6 ounces, and you could put a point here in the middle and the whole thing would balance. So that's the concept of balance and weight distribution. Thank you for joining me today and building your marshmallow structures. This is an example of STEM education, or science, technology, engineering, and math. We encourage all of you to pursue any one of those fields or a combination of those fields, as those skills and learned capabilities are so necessary in our society and in everyday life. And I hope that you enjoyed our project today. I encourage you to stay tuned for the next session.